So imagine you're in the supermarket, you're buying some groceries, and you get given the option for a plastic or a paper shopping bag. Which one do you choose if you want to do the right thing by the environment? Most people do pick the paper. Okay, let's think of why. It's brown to start with, therefore it must be good for the environment. It's biodegradable, it's reusable, in some cases it's recyclable. So when people are looking at the plastic bag, it's likely they're thinking of something like this, which we all know is absolutely terrible and we should be avoiding at all expenses, these kinds of environmental damages. But people are often not thinking of something like this, which is the other end of the spectrum. When we produce materials, we need to extract them from the environment and we need a whole bunch of environmental impacts. You see, what happens is when we need to make complex choices, us humans like really simple solutions, and so we often ask for simple solutions. And I work in design, I advise designers and innovators around sustainability, and everyone always says to me, "Oh, Leyla, I just want the eco-materials." And I say, well, that's very complex, and we'll have to spend 4 hours talking about what exactly an eco-material means, because everything at some point comes from nature. And it's how you use the material that dictates the environmental impact. So what happens is we have to rely on some sort of intuitive framework when we make decisions. So I like to call that intuitive framework our environmental folklore. Okay, it's either the little voice at the back of your head, or it's that gut feeling you get when you've done the right thing. So when you've picked the paper bag, or when you've bought a fuel-efficient car. And environmental folklore is a really important thing because we're trying to do the right thing. But how do we know if we're actually reducing the net environmental impacts that our actions as individuals and as professionals and as a society are actually having on the natural environment? So the thing about environmental folklore is it tends to be based on our experiences, the things we've heard from other people. It doesn't tend to be based on any scientific framework. And this is really hard because we live in incredibly complex systems. We have the human systems of how we communicate and interrelate and have our whole constructed society, of the industrial systems, which is essentially the entire economy. And then all of that has to operate within the biggest system, and I would argue the most important, the ecosystem. And you see, the choices that we make as an individual, but the choices that we make in every single job that we have, no matter how high or low you are in the pecking order, has an impact on all of these systems. And the thing is that we have to find ways, if we're actually going to address sustainability, of interlocking those complex systems and making better choices that result in net environmental gains. What we need to do is we need to learn to do more with less. We have an increasing population, and everybody likes their mobile phones, especially in this situation here. So we need to find innovative ways of solving some of these problems that we face. And that's where this process called life cycle thinking comes in. So essentially, everything that is created goes through a series of life cycle stages. And we use this scientific process called life cycle assessment, or in America you guys say life cycle analysis, in order to have a clearer picture of how everything that we do in the technical part of those systems affects the natural environment. So we go all the way back to the extraction of raw materials. And then we look at manufacturing, we look at packaging and transportation, use and end of life. And at every single one of these stages, the things that we do have an interaction with the natural environment, and we can monitor how that interaction is actually affecting the systems and services that make life on Earth possible. And through doing this, we've learned some absolutely fascinating things. And we've busted a bunch of myths. So, to start with, there's a word that's used a lot. It's used a lot in marketing, and it's used a lot, I think, in our conversation when we're talking about sustainability. And that's the word biodegradability. Now, biodegradability is a material property. It is not a definition of environmental benefit. Allow me to explain. When something natural, something that's made from a cellulose fiber, like a piece of bread even, or any food waste, or even a piece of paper, when something natural ends up in the natural environment, it degrades normally. Its little carbon molecules that it stored up as it was growing are naturally released back into the atmosphere as carbon dioxide. But this is a net situation. Most natural things don't actually end up in nature. Most of the things, the waste that we produce, end up in landfill. Landfill is a different environment. In landfill, those same carbon molecules degrade in a different way because a landfill is anaerobic. It's got no oxygen. It's tightly compacted and hot. Those same molecules, they become methane. And methane is a 25 times more potent greenhouse gas than carbon dioxide. So our old lettuces and products that we have thrown out that are made out of biodegradable materials, if they end up in landfill, contribute to climate change. You see, there are facilities now that can actually capture that methane and generate power, displacing the need for fossil fuel power. But we need to be smart about this. We need to identify how we can start to leverage these types of things that are already happening and start to design systems and services that alleviate these problems. Because right now, what people do is they turn around and they say, let's ban plastic bags, we'll give people paper because that is better for the environment. But if you're throwing it in the bin and your local landfill facility is just a normal one, then we're having what's called a double negative. Okay, I'm a product designer by trade, then did social science, and so I'm absolutely fascinated by consumer goods and how the consumer goods that we have kind of become immune to, that fill our lives, have an impact on the natural environment. And these guys are like serial offenders. And I'm pretty sure everyone in this room has a refrigerator. Now, America has this amazing ability to keep growing refrigerators. In the last few years, they've grown 1 cubic foot on average, the standard size of a refrigerator. And the problem is they're so big now. It's easier for us to buy more food that we can't eat or find. I mean, I have things at the back of my refrigerator that have been there for years. All right? And so what happens is we waste more food. And as I was just explaining, food waste is a problem. In fact, here in the US, food waste, 40% of food purchased for the home is wasted. Half of the world's produced food is wasted. That's the latest UN stats. Up to half of the food. It's insane. It's 1.3 billion tons of food per annum. And I blame it on the refrigerator, well, especially in Western cultures, because it makes it easier. I mean, there's a lot of complex systems going on here. I don't want to, make it so simplistic, but the refrigerator is a serious contributor to this. And one of the features of it is the crisper drawer. You all got crisper drawers, the drawer that you put your lettuces in? Lettuces have a habit of going soggy in the crisper drawers, don't they? Yeah? Soggy lettuces. In the UK, this is such a problem that there was a government report a few years ago that actually said the second biggest offender of wasted food in the UK is the soggy lettuce. It was called the Soggy Lettuce Report. Okay, so this is a problem, people. These poor little lettuces are getting thrown out left, right, and centre because the crisper drawers are not designed to actually keep things crisp. Okay, you need a tight environment. You need an airless environment to prevent the degrading that would happen naturally. But the crisper drawers, they're just a drawer with like a slightly better seal. Anyway, clearly obsessed, all right? Don't ever invite me over because I'll just start going through your refrigerator and looking at all sorts of things like that. But essentially, this is a big problem because when we lose something like the lettuce from the system, not only do we have that impact I just explained at the end of life, but we actually have had to grow that lettuce. The life cycle impact of that lettuce is astronomical. We've had to clear land. We've had to plant seeds, phosphorus, fertilizers, nutrients, water, sunlight, all of the embodied impacts in that lettuce get lost from the system, which makes it a far bigger environmental impact than the loss of the energy from the fridge. So we need to design things like this far better if we're going to start addressing serious environmental problems. We could start with the crisper drawer and the size. For those of you in the room who do design fridges, that would be great. Okay, so the problem is, so imagine if we actually started to reconsider how we designed things. So I look at the refrigerator as a thing that, it's like a sign of modernity, but we actually haven't really changed the design of them that much since the 1950s, a little bit. But essentially, they're still big boxes, cold boxes that we store stuff in. So imagine if we actually really started to identify these problems and use that as the foundation for finding innovative and elegant design solutions that'll solve those problems. This is design-led system change. Design dictating the way in which the system can be far more sustainable. 40% food waste is a major problem. Imagine if we designed fridges that halved that. Another item that I find fascinating is the electric tea kettle, which I found out that you guys don't do tea kettles in this country really, do you? But that's really big in the UK. 97% of households in the United Kingdom own an electric tea kettle. So they're very popular. And I mean, if I were to work with a design firm or a designer and they were designing one of these and they wanted to do it eco, they'd usually say, they'd ask me two things. They'd say, Leyla, how do I make it technically efficient? Because obviously energy is a problem with this product. Or how do I make it green materials? How do I make the materials green in the manufacturing? Would you ask me those questions? They seem logical, right? Yeah. Well, I'd say you're looking at the wrong problems, because the problem is with use. It's with how people use the product. 65% of Brits admit to overfilling their kettle when they only need 1 cup of tea. All of this extra water that's being boiled requires energy. And it's been calculated that in 1 day of extra energy use from boiling kettles is enough to light all of the street lights in England for a night. But this is the thing, right? This is what I call a product person failure, but we got a product system failure going on with these little guys. And they're so ubiquitous, you don't even notice they're there. And this guy over here, though, he does. His name's Simon. Simon works for the National Electricity Company in the UK. He has a very important job of monitoring all of the electricity coming into the system to make sure there is enough so it powers everybody's homes. He's also watching television. The reason is because there's a unique phenomenon that happens in the UK the moment that very popular TV shows end. The minute the ad break comes on, this man has to rush to buy nuclear power from France because everybody turns their kettles on at the same time. 1.5 million kettles, seriously problematic. So imagine if you designed kettles, you actually found a way to solve these system failures, because this is a huge amount of pressure on the system just because the product hasn't thought about the problem that it's going to have when it exists in the world. Now, I looked at a number of kettles available on the market and found the minimum fill line, so the little piece of information that tells you how much you need to put in there, was between 2 and 5.5 cups of water just to make 1 cup of tea. So this kettle here is an example of one where it actually has 2 boiling chambers, or sorry, 2 reservoirs. One's a boiling chamber and one's the water holder. The user actually has to push that button to get their hot water boiled, which means, because we're all lazy, you only fill exactly what you need. And this is what I call behavior-changing products. Products, systems or services that intervene and solve these problems up front. Now, this is a technology arena, so obviously these things are quite popular. But I think if we're going to keep designing, buying, and using and throwing out these kinds of products at the rate we currently do, which is astronomically high, there are 7 billion people, right, who live in the world right now. There are 6 billion mobile phone subscriptions as of last year. Every single year, 1.5 billion mobile phones roll off production lines, and some companies report their production rate as being greater than the human birth rate. 152 million phones were thrown out in the US last year, only 11% were recycled. I'm from Australia, we have a population of 22 million, don't laugh, and it's been reported that 22 million phones are in people's drawers. We need to find ways of solving the problems around this, because these things are so complicated. They have so much locked up inside them. Gold. Did you know that it's actually cheaper now to get gold out of a ton of old mobile phones than it is out of a ton of gold ore? There's a number of highly complex and valuable materials embodied inside these things, so we need to find ways of encouraging disassembly, because this is otherwise what happens. This is a community in Ghana, and e-waste is reported, or electronic waste is reported by the UN as being up to 50 million tons trafficked. This is how they get the gold and the other valuable materials out. They burn the electronic waste in open spaces. These are communities, and this is happening all over the world. And because we don't see the ramifications of the choices that we make as designers, as business people, as consumers, then these kinds of externalities happen, and these are people's lives. So we need to find smarter, more systems-based, innovative solutions to these problems if we're going to start to live sustainably within this world. So imagine if, when you bought your mobile phone, your new one, because you replaced your old one, after 15 to 18 months is the average time that people replace their phones, by the way. So if we're going to keep this kind of expedient mobile phone replacing, then we should be looking at closing the loop on these systems. The people who produce these phones, and some of which I'm sure are in the room right now, could potentially look at doing what we call closed-loop systems or product system services. So identifying that there is a market demand and that market demand is not going to go anywhere, so you design the product to solve the problem. Design for disassembly, design for lightweighting. We heard some of those kinds of strategies being used in the Tesla Motors car today. These kinds of approaches are not hard, but understanding the system and then looking for viable, market-driven, consumer demand alternatives is how we can start radically altering the sustainability agenda. Because I hate to break it to you all, consumption is the biggest problem. But design is one of the best solutions. These kinds of products are everywhere. By identifying alternative ways of doing things, we can actually start to innovate. And I say actually start to innovate, I'm sure everyone in this room is very innovative, but in the regards to using sustainability as a parameter, as a criteria for fueling systems-based solutions. Because as I've just demonstrated with these simple products, they're participating in these major problems. So we need to look across the entire life of the things that we do. If you just had paper or plastic, obviously reusable is far more beneficial. Then the paper is worse. And the paper is worse because it weighs 4 to 10 times more than the plastic. And when we actually compare from a life cycle perspective a kilo of plastic and a kilo of paper, the paper is far better. But the functionality of a plastic or a paper bag to carry your groceries home is not done with a kilo of each material. It's done with a very small amount of plastic and quite a lot more paper. Because functionality defines environmental impact. And I said earlier that the designers always ask me for the eco-materials. I say, you know, there's only a few materials that you should completely avoid. The rest of them, it's all about application. And at the end of the day, everything we design and produce in the economy or buy as consumers is done so for function. We want something, therefore we buy it. So breaking things back down and delivering smartly, elegantly, sophisticated solutions that take into consideration the entire system and the entire life of the thing, everything, back all the way back to the extraction through to the end of life, we can start to actually find really innovative solutions. And I'll just leave you with one very quick thing that a designer said to me recently, who I work with, a senior designer. I said, how come you're not doing sustainability? You know this. And he said, well, recently I pitched a sustainability project to a client, and he turned to her and said to me, I know it's going to cost less. I know it's going to sell more. But we're not pioneers because pioneers have arrows in their backs. I think we've got a room full of pioneers, and I hope there are far more pioneers out there because we need to solve these problems. Thank you.